expenses of territorial community at the oblast, like region level, regarding wages, statistical information of actual accruals. Here you can see from 2014 to 2023, as well as information on the schedule for 2024 and part of available actual data of the current year on this table. And we have been used for methods. The first one, called profit, is an adaptive approach to time series forecasting. The second one is SARIMA, complex time series model. The third one, also known as triple exponential forecasting, is called Winters model. And the last one, and the best one, as we think, is a special type of recurrent neural networks, long and short time series models. So regarding all these four models, I will make a short review of received data. The first one is a profit. Profit is suitable for case at hand, after which it can handle irregular time series, affect seasonality and trend, and automatically detect changes in trends. One of the key features of the profit is its robustness to missing data and outliers, as well as its ability to automatically detect changes in trend. The model uses a Bayesian approach to estimate model parameters. This makes it possible to obtain not only point forecast, but also confidence intervals, which is critically important for the estimating of the uncertainty of forecast. The model demonstrates the ability to generate forecasts that can be used for planning and financial decision making. The second one is SARIMA. SARIMA method provides a clear statistical basis for interpreting the results, which is important for statistical analysis. The analysis of the obtained data allows us to conclude that in comparison of the profit model, the accuracy of forecasting using the SARIMA model is higher. Holt-Winters model, also known as triple exponential smoothing, is used to the time series with trend and seasonality. It is a powerful tool for forecasting time series, especially for those exhibit seasonality. The model effectively measures seasonal patterns in the data, which is significant for many economics and environment time series. The model constantly adapts to changes in trend and seasonality, making it robust to predict structural changes in the data. The components in the model, level, trend, and seasonality, are easily interpreted. So the model often shows high accuracy for short-term forecast and work even with short time series. The next one is Holt-Winters adaptive model, has advantages over the multiplicative model given the nature of the time series. Take into account the constant amplitude of seasonal fluctuation, the linearity of the trend, the disturbance of growth variations over the time, the stability of low values, and the experience of correlation regulation analysis of the data. The additive model shows more accuracy in the simulation results. The analysis of the obtained data allows us to conclude that Holt-Winters model has a higher forecasting accuracy compared to Profit and SARIMA models. But it has significant limitation regarding the impossibility of working out long-term forecast periods within expected accuracy. So the last one is LSTM model, takes into account the particularity of model of data. Model can examine annual seasonality by using 12 months tournaments. The model is able to capture long-term trends in the data. The model shows complex non-linear relationship in the time series, and the projection of transformed back the original state using inverse transform. A seasonality factor of 1.127 is applied from July to account for expected changes of seasonal patterns. On these figures, you can see the graphical interpretation of forecasting of payroll expenses using this model. So, as conclusion, our research updates the issue of developing modern methods of liquidity management using models for forecasting the flow of funds on boiler accounts of local budgets. One of the most urgent tasks of local financial bodies in this context of ensuring budget process is the construction of forecast within the framework of medium-term forecasting. The demonstrated advantages of the models using AI over regression models of numerical series in long-term planning tasks are clearly promising for use by local financial authorities. As a result of practical implementation of the models within the use of initial data, graphical interpretation of the work of the models were obtained as example on example of wages, and the differences between forecast and actual data were analyzed. A more practical and distressing future task is a collection of sufficient amount of data to build larger model on which we can, within the frameworks, to provide recommendations for the practical implementation of the proposed solution for modeling the processes of managing the liquidity of local budgets using modern AI and ML tools. Thank you very much for your attention. In case of any questions, I will be glad to provide you with answer. Thank you.
Thank you, Alexander. Thank you very much. Excellent, excellent. Any questions?
Thank you.
Hi, my name is Alexander. I have one question. First one, what parameters have you used for forecasting?
Yes, we have been used. Let me come back. For forecasting, we have been used the wages for one region. It's Cherkasska Oblast. For this, we used the wages. And on the level of wages and circumstances of Ukraine, I mean war and other, you can see on the models that we have a difference, and statistical methods have will have will be not so efficient than modern ML-related models of financial forecasting.
Unfortunately, I have seen only results your forecasting, but without parameters. My question was about type of parameters did you use for the forecasting? For example, input data or something else. Thank you.
Yes, in our research, and it is described, we used not only the wages, but also time series, and also historic data for these data sets. And we describe the formulas for every of this method.
Thank you very much. I have next question. How did your model do self-assessment?
What do you mean self-assessment?
Self-assessment.
You mean
You used artificial model. You should make a self-assessment for each model.
we checked by historical data. So we prove that the model work, and as you can see, we had received actual data and check on forecast.
If you use artificial intelligent model, uh, you should study your model and make self-assessment for each models.
Yes, you are right. On our current research, we have been used this for machine learning models and receive expected results. The next step will be, as here I show on our on our shim will be model validation and training data. So it's the next step of our current research will be used for sure. So we
Okay.
want to increase data to get another input, and we want to train our model.
Thank you very much for your answers.
Thank you,
Thank you
Alexander.
very much, Alexander. Both of you, very nice questions and answers. Thank you very much.
Thank you.
The next